So why do good girls like bad guys? I had this question for a real long time.
Nick would turn the micrometer and I would count the fringes as I saw them going by. I counted a total of 25 fringes, and then we took how far the micrometer was turned.
So we repeated our procedure for measuring wavelength with the sodium source, again counting 25 fringes passing and recording the distance traveled on the micrometer.
And so for measuring the wavelength of the mercury and sodium sources, we use this equation. The reason there's a factor of 2 in there is because for the calibration factor, which we measured from lab 6, given over here, that was for the OPD and not for the waves, so that's why we have a factor of 2. And for the wavelength of the mercury source, we got 621.6 nanometers. For the wavelength of the sodium source, we got 685.5 nanometers. So there's quite a bit of error, but we were eyeballing the amount of fringes we saw, so we expect a little bit of error.
Here's an example of two similar frequency cosine waves squared to show the intensity pattern. The theory behind this for measuring the sodium doublet is to measure the separation between the areas of minimum fringe contrast as seen here, which will give us the period of the envelope. For this experiment, we found a point where we have minimum fringe contrast and we measured the micrometer position with calipers. Then we crank the micrometer through the area of high contrast back into another area with low contrast until we find the minimum contrast again, somewhere around here. And then we measure the micrometer position again with the calipers and figure out the micrometer travel from that.
So for measuring the spectral range of the sodium source, we were using this equation, which again we have the factor of 2 because our calibration factor from last lab was for OPD and not waves. And D source is the difference in these two values, which we then converted to nanometers in the equation. And we did it twice, one using our experimental sodium wavelength and one using the given sodium wavelength. We calculated a delta lambda of 0.666 nanometers and delta lambda of 0.492 nanometers when the given delta lambda was 0.6 nanometers. For the refractive index of air experiment, we counted 20 fringes that passed as we pumped the air out of the vacuum chamber.
From our refractive index of air experiment, we calculated a slope delta n over delta p of 3.71 times 10 to the minus 6, which we then used to calculate the y-intercept, which we then used to plot the refractive index of air versus pressure. And finally, we calculated the refractive index of air in Tucson at this very moment of 1.000435.